Personal finance practice problem using Excel. Rule of 72 and running balance calculation problem number 3. Prepare to get financially fit by practicing personal finance. Here we are in our Excel worksheet. If you have access to the Excel worksheet, would like to follow along, note that we're down here in the practice tab as opposed to the example tab. The example tab in essence being an answer key. We have the information on the left-hand side. We're going to populate that into the blue area on the right-hand side. This is the third problem of a similar nature. Notice as we populate this problem, we're going to do something a little bit different with regards to just maneuvering around in Excel. We're going to try to use the keyboard a little bit more than what we did in prior presentations when we did more of the point and click with the mouse, using the keyboard and the arrows being a little bit faster, a little bit more efficient. So we're going to practice that. Our information on the left-hand side is we have the yearly earnings percent in a savings account is 18%. Now note, obviously that's high for most time periods, at least in the United States, but we want to basically use a higher percentage rate for practice, and note that you can have basically a rate like that one in different types of accounts. If it was like an investment account or a stock account or something like that, you might have a higher rate, or estimating a return that you might have for something like a home, then you might see a higher rate like that as well. Also note that no matter what the rates currently are for you, then you could end up with periods of high or lower inflation rates some point in the future, which can be a little bit difficult to imagine if you're in a period of very like one set of rate. If the rates are really low for a long period of time, in other words, it becomes difficult to imagine rates going up and inflation taking place and whatnot. And if you've been in a period of inflation for a period of time, it's kind of difficult to imagine, that you'd ever be able to get the thing under control and have rates go down. When you're doing your financial investments, you want to take into consideration that most likely, or at least hedge against the fact that inflation rates, whatnot, will most likely change over your lifetime, and you want to basically be taking that into consideration with your risk assessment and understanding the severe impact that can have on your different investment strategies. So we have how long will it take for the account to double? So we can answer that question then without even having an investment amount, and then we will consider the investment amount, in this case being $3,000, to think about if you had $3,000 as just simply a starting point, how long would it take to double? In other words, how long would it take to get to $6,000? So we're looking for the period of time then for it to double. We'll start off with the rule of 72, which is kind of a shortcut type of method, and then we'll go to different methods as we work through the practice problems, including a running balance in this presentation. So we're going to build our tables. We want to work on good practices with the tables, taking our information as much as possible from the data set on the left-hand side, starting with the rule of 72. Straightforward calculation. We're going to make it a little bit longer just to make sure that we understand it a little bit better. I'm going to type in rule of 72. We're going to start off in the outer column simply hard coding or typing in 72, which is not something we normally do because we usually take our information from the data. But given this is the rule of 72, we're simply going to hard code that first number in place. Then we're going to take the rate. Now, normally you just basically divide by the rate, but we want to make sure that we understand what we mean by the rate when we're talking about the rule of 72, because the rate can be expressed here in format of a percent, in the format of a decimal, 0.18, or in this case, we want to kind of convert it to an actual dollar amount or an actual number of 18. So the way we're going to convert it, instead of just typing it in here, I want to say equals, and now I'm going to use my keyboard and start practicing with my arrows instead of the mouse. And this is what's kind of new here with our Excel practice. I'm going to say left, 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 up on the keyboard. Notice the changing number here. We're now on cell B2. I'm going to say enter. I'm going to hit the up arrow, go back on that cell. I need to change it so I can see something in that cell by going to the Home tab, Numbers group. I could add some decimals. There's the 0.18. Or we could then change it to a percent, moving the decimal 2 places to the right effectively and adding, in essence, a percent. So there we have the 18%. Now what we're going to do is multiply that times 100 because the rule of 72 really wants 18 in number format, not in the format of a percent or decimal equivalent. So I'm going to go back on over here, Home tab, Font group, underline that. I'm going to take this to the outer column, multiplying those two out. So I'm going to do that with the equal sign. I'm going to say left arrow, up arrow, up arrow. So there we are in E3. Note when I multiply and I say times, if I say any kind of multiplication or adding or subtracting, any mathematical kind of function there, and then go to the left again, it's not going to start from the 18. It's going to start down here on this cell. So I'm going to lay left and then up. Takes me to the 100. So there's the E3 times E4 and enter. That gives us our 18 just in terms of dollars. I'm going to go to the Home tab, Font Group, and Underline. And then finally, we're going to get this as the amount of the years to double. And I'm going to go ahead and just divide this out, the two numbers in the outer column. This is going to be equal. I'm going to hit the up arrow now, up, 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 up. The F2 divided by up arrow one time, F5, and enter. We have 4. I think it is even in this case, which is simply an estimate. It's not actually exactly that number, but it's an estimate from the rule of 72. I'm going to add some decimals anyways. Home tab, number, adding a couple decimals, about 4 years. So it'll take about 4 years to double. That means if we're starting with the 3,000, it takes us about 4 years to get to the 6,000 if we're starting with, if we have an 18% growth rate, which would be quite high if inflation, was low and so on. Okay, so let's go ahead and hide some cells now, and let's see how that would look in terms of a running balance calculation. Really useful thing to be able to do as a running balance calculation. Before we do, let's hide some cells. I'd like to see this column over here, column H, right next to our data. So I want to hide from cells C to F. Let's hide from cell C to F. I'm going to put my cursor on the column C, the little skinny column, and then I'm gonna drag on over to column F. And so I still want this space from column G, so I'm not going to delete that one or hide it. Don't delete them, by the way, hide them. Then right-click on the selected area and hide, not delete, but hide. So now it's been hidden, so we could see that up top between B and G, there's hidden columns there, because that's not how the alphabet goes. It doesn't go from B to G. There's like letters in between that. I know there's at least a C in there somewhere. So now we're going to do our running balance kind of calculation. I'll start with the years. I'm going to say 0, 1. I want to start with year 0, 2, and so on. I would then like to select these cells and have Excel help me out to do the rest of the calculations, which I could have just typed in there. But if you're talking about a long series of numbers, it's quite easy to do with Excel with the autofill, putting our cursor on the autofill handle, left-clicking on it, dragging it on down to get to 5. Then I'm going to go to the Home tab. Alignment group, let's center those just to make them look a little bit nicer. Looks way nicer. Like, you don't have to do that, but I think it looks nicer. And then we're going to start with the investment at the 3,000. I'm not going to type it in there because we're going with our theory of bringing the information from our data set so that if we wanted to test it out, what would happen if it was 6,000 or something, we can do that. So I'm going to say equals, using the arrows again, down, 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 left, 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 left. Now we're on B7, that's what we want, and enter. So now let's multiply this out. So we're going to multiply it out in the interest. This is 1 year out. We're going to take the 3,000 times 18%. You can do that in a calculator, 3,000 times 0.18 or 18%. I'm going to do that with Excel, pulling the information from the 3,000 here and the 18 on the left. Noting that we're thinking about later copying this down, which we will do. Anything that's outside your blue area, the table you're working in, anything that's in the data set, when you copy it down, likely it will need to be absolute reference. In other words, you'll need to tell Excel, don't move this cell down. We'll do that later. We won't do it yet. So I'm going to say equals, right arrow, up arrow. There we are on J2. I'm going to say times. That brings me back into this cell, and then I'm going to say left from that cell, left, left, and up to the 18, and enter. There's the 540. Now I'm going to add that to the 3,000 using our cell references, equals, up arrow, that brings me to the 3,000, plus, that brings me back into this cell, left arrow, there's the 540, and enter. Let's do it again. Now we've got a new balance of the 3,540 times the 18%. The interest is increasing because it's compounding. This is equals. I'm going to go right arrow and then up to J3 times. That pulls me back into this cell in I4. So when I go left, I'm coming from that cell up to the 18. So J3 times B2 and enter. Then I'm going to add these two up again. Equals, up arrow, the one above it, plus That brings me back into this cell, left arrow, the one to the left of it, and enter. Let's do it at least one more time here. So now we got the 4,177 at the starting point equals right arrow, up arrow, 4,177 in J4. Then I'm going to say times, bringing us back into the cell in J5, left, 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 up, up, up. So there's the J4 times B2 and enter. And then we're going to go back over here in J5 equals up arrow once plus left arrow once, and there we have it, and so on and so forth. Now we're going to go back and say, what if I tried to copy this down and do this more quickly? I'm going to actually delete what we have done thus far so we can do that the easy way. This is the long way. Let's do it the easy way. So I'm going to delete this. I'm going to start at the same point, which will be equals right arrow up the 3,000 plus left, left, left up the 18, or times the 18, I'm sorry. 3,000 times 18% or 0.18. And then we're in the 3,000 plus the 540, which will be equals up to the 3,000 J2 plus left to the 540 in I3. I'm going to test this out. It's going to have a problem when I autofill it. I'm going to select these two cells, say what would happen if I copied this down using the fill handle, putting my cursor on the fill handle, dragging down. Does it do what I want it to do? It looks like it has a problem there. Let's double click on it. The problem being that 18 needs to be absolute referenced, right? Because it's moving down. It moved down. I don't want it to move down because it's outside the table. Anything that's outside your table from a data set often is the thing that you're going to need to make an absolute reference if you copy it down. So I'm going to delete what happened here and say, okay, I'm going to fix that then. I'm going to fix it. That's not a problem. That's not a problem. So this one in cell B2, we're going to make that an absolute reference, putting our cursor in B2. You could do this by selecting F4 on the keyboard, putting a $sign before the B and the 2. You only need a mixed reference, $sign, because you're only copying down here. But an absolute reference is usually easier conceptually just to understand, just telling Excel, don't move that cell when I copy it somewhere. So we'll say OK. Oftentimes I will test this by taking it down one cell just to make sure it does what I want it to do, unless I'm confident, and then I would bring it all the way down. I'm confident here, but I'm still going to test it because that's what I'd do if I wasn't confident. So I'm going to autofill it down, and then I'm just saying, is it doing what I want it to? Let's double click that one. Yeah, it kept that one the same. B2 didn't move. This one did move down, just like it should, from the 3,000 to the 3,540. This one moved down. This one looks a little complex, but everything's inside the table. It moved down just like it would, just like it should. So we're going to say, okay, let's copy it on down and just see that should do it the whole way. I'm going to select these two, put my cursor on the fill handle here, and just left click, drag it on down to the 5 periods. And there we have it. Now we can see the interest increasing. We can see the impact on the investment. Note there are decimals involved. So if you wanted to see the pennies here, you could select this whole thing. We could go to the home tab, number group, add a couple pennies and get the pennies involved there. And we could see then that sometime between year 4 and year 5, we got to 6,000. So a little bit over year 4. So it's not exactly 4 years as we got with the rule of 72, but it's close. It's around there. Next time we'll do more exact calculations with the Excel functions. Before we do, let's go ahead and unhide the cells up top. So now we got these cells. Let's unhide by putting our cursor on column B, dragging over to H, and then let go, right-click the selected area, and then unhide those cells. So there we have it. So there we have our 4 with the rule of 72. A little bit over 4 we can see with our running balance. We could make it more exact with this running balance to try to figure out the fraction of a year and whatnot. But we'll leave it there for now, and we'll get to those more exact calculations over here next time when we start to do our calculations with functions in Excel. Then we'll use tables, and then we'll use the mathematical formulas to do the same stuff.